Hello everyone, this is Anita. Welcome to the machine learning video lecture series. In this video, we will understand the ensemble learning technique, that is boosting and the stacking. So let's get started. So this boosting and stacking are the advanced ensemble learning technique. So we will understand one by one. So first let us understand what is boosting. So boosting refers to the process of creating a strong learner from the collection of the weak learner, or we use the boosting for combining the weak learner with the high bias. So here weak learner is a model that perform only slightly better than the random guessing on the training data. Or in another way we can say that weak learner haven't learned much from the training data. So this boosting is an ensemble learning technique that aims to improve the predictive accuracy of the model by combining the multiple weak learners. So here our aim is to improve the predictive accuracy of the model by combining the multiple weak learner, and that weak learner are the homogeneous. So boosting involves sequentially training the weak learner. So this we will understand with the help of example. So here in this diagram, we have taken the one data set, and here the sample of data is first taken from this initial data set, and this sample is used to train the first model. So here that model is the decision tree model. So here we have written DT1. So this is the weak learner. So the sample is used to train the first model, and the model makes its predictions. So here the sample, like it can either be correctly or incorrectly predicted. So the sample that are wrongly predicted are reused for the training of the next model, that is the DT2. So whatever wrong prediction is generated by the DT1, so that we are passing for the training purpose to the DT2. So similarly we will do till DTN. So here subsequent model can improve on the errors of the previous model, and at the end we will generate the strong learner. So all here DT1, DT2, DT3, so all we can say these are the weak learner. So here boosting internally uses the decision tree, and that decision tree are sequentially connected. So this boosting aggregates the result at each step, and they are aggregated using the weighted averaging. So here they are using the weighted averaging method. So this weighted averaging, it involves giving all the models a different weight depending on their predictive power. So here in other word we can say that it gives more weight to the model with the highest predictive power, and this is because the learner with highest predictive power is considered the most important. So if I want to write a function of this boosting, so this is how we can write. So this f is nothing but the function. So f is equal to alpha 1 into m1. So this m1, m2, m3, mn, these are the models. So this model we can say decision tree 1, 2, 3 likewise, and they are connected sequentially. So that's why I have used here plus symbol. And along with this model, we are using the confidence, or we can say weight we are using. So that confidence is nothing but the we are giving the some weightage to the model. So that alpha 1, alpha 2, alpha 3, alpha n, these are the weights, and these weight we are multiplying with the model. So this is how you can write the boosting function. So this internally this boosting technique takes all the model sequentially along with its weight. So now let us understand the types of boosting. So in boosting we have the ADA boost, gradient boost and the XGBoost. Now we will understand the process of boosting. So here you can see the first training data set is there. So initially we are taking some sample of data from this training data set, and then that some sample of subset we are passing to for training to the first model or the first weak learner. So let's consider here decision tree is there. So we are passing to the decision tree. Then we test that train weak learner using our testing data or the that test data set, and as a result of that testing, some data points will be incorrectly predicted or the some false prediction will be there. So that data, so each data point with that wrong prediction is sent to the into the second subset of data, and this second subset of data is updated, and again it is passed to the next weak learner, that is the decision tree 2. Again that using that updated subset we train and test the second model. So we continue with the following subset until the total number of subset is reached, and finally we got the predictions. So we are having that total predictions, and the overall predictions has already been aggregated at each step. So there is no need to calculate it again. So this is how that this process, this boosting process happen, and it uses the sequential approach. Now we will understand the benefits of the boosting technique. So the first benefit is the improved accuracy. So here this boosting algorithm, it significantly enhances the accuracy of the predictive model by combining the weak learner. So ultimately our aim is to improve the accuracy by combining the multiple weak learner. Now the second one is the handling the complex data. So here boosting is effective in handling the complex data by combining the multiple weak learners. And this boosting algorithm can capture the non-linear patterns and the interactions in the data. Next is feature importance. So boosting algorithm provide insights into the feature importance. And next one is the reduces bias. So here bias is presence of uncertainty or inaccuracy in the machine learning results. So this boosting algorithm combine the multiple weak learner in a sequential manner, and then which iteratively improve the observations, and this approach helps to reduce the high bias that is common in the machine learning models. And the last one is the computational efficiency. So here the boosting algorithm, it prioritizes the features and that increase the predictive accuracy during the training, and they can help to reduce the data attributes and handle the large data set efficiently. So this is how boosting helps in increasing the accuracy. Now, let us understand the next technique, that is the stacking. So, this stacking is also called as a stack generalization. We use stacking to improve the prediction accuracy of the strong learner. So, here the stacking aims to create a single robust model from the multiple heterogeneous model. Here in stacking we are combining the results of the multiple heterogeneous strong learner. So stacking differ from the bagging and boosting in it combines the strong learner, it combines the heterogeneous model, and it consists of creating a meta model, and that meta model is a model created using a new data set. So here that individual heterogeneous model are trained using the some data, and then that model make the predictions and form a single new data set, and using those predictions we are creating the that meta model. So we will understand the process of the stacking with the diagram. So here you can see we use the initial training data set to train this number of algorithms, and these number of algorithms are the different or the heterogeneous strong learners we can say, and using the output of each of these algorithm we create a new training data set, and using that new training data set we create a meta model, and using the result of this meta model we make a final predictions, and the results are combined using the weighted averaging. So here also we are using the weighted averaging method. This is the example of the stacking. So here you can see some data is there, and with that data we have used the different models, and at the end this meta model here, the logistic regression meta model is there. So this is the diagram. In stack model with meta learner is the logistic regression, and the weak learners are the decision tree, random forest, k neighbors classifier, XGBoost. So this is how the stacking technique works. Now we will understand when to use this bagging, boosting and stacking. So here bagging, boosting and stacking are the vital technique in the ensemble learning. Here when you want to reduce the variance, so that time we use the bagging technique. If you want to reduce the bias, so that time you use the boosting technique. And if you want to improve the prediction accuracy, so that time you use the stacking technique. And this bagging and boosting, they combine, or they are using the homogeneous weak learner, where the stacking uses the heterogeneous strong learner. This bagging uses the parallel technique for the training purpose. Boosting uses the sequential uh, method for the training, and this stacking uses the meta model, or it creates the meta model. Here, bagging uses the max voting and the averaging as the aggregation method, and boosting and stacking uses the weighted averaging as a aggregation method. So this is how this boosting and stacking works. Thank you.